Do our third video on polar coordinates, and in this video let's just keep going and let's keep using our conversions where r squared equals x squared plus y squared, right, where the tangent of theta equals y over x, r sine of theta equals the y value, and then r cosine of theta equals x, right? These are the equations that can carry us through all of these conversions. So for example, and I think you might have noticed this in the last video, we had started off with a point, right? Let's say again, I don't know, this time 9 100 degrees, and then we said, well, what would this be in radians? Well, this is this is radians, sorry. What would this be in as a Cartesian point? Alright, so how do we turn r equal to 9 and theta equal to 100 into x and y? We used these right here, that r times the sine of theta, so 9 times the sine of theta equals the y value, and then 9 times the cosine of theta equals the x value. So, and I should have wrote that in here, but in this case, right, theta is equal to 100. So instead of just writing theta, let's write 100 in. So what we did was we figured out what's the sine of 100. What is the cosine of 100, and multiplied that by 9. We enter this on our calculator, so you can get 9 times the sine of 100, and that's just equal to negative 4 point, let's round it, negative 4.6. So that's our y value, negative 4.6. And our x value is 9 cosine of 100, and that is equal to 7.8. I'm rounding the nearest tenth place. So basically, this is how we got our y value and our x value. And then we make a jump to functions, right? So we're going beyond points here. We're saying, well, what if you're given an equation? Let's try one. What if you're given, I don't know, 5y minus 3x equals 10. So I'm not looking for a point here. I'm saying, how can you get rid of the x and y variables and put in r's and thetas? And I want this that we could say in terms of theta. So you want to say r equals something. How can we do that? Well, let's just substitute, right? Y equals r times the sine of theta. So instead of 5 times y, we get 5 times r sine of theta minus 3, well, r cosine of theta, and that equals 10. And what we're going to do is distribute the 5 and the 3, so we get 5r sine of theta minus 3r cosine of theta is equals 10. You factor out the r, so you get r times 5 sine of theta minus 3 cosine of theta equals 10. And let's write this in terms of theta. So we want to have r equals, and we can write that right over here, r equals 10. We're going to divide now both sides by this big term. We get 10 divided by 5 sine of theta minus 3 cosine of theta. And that's actually it, right? Because our goal was to rewrite this function in terms of r and theta, and we did. R equals 10 over 5 sine of theta minus 3 cosine of theta. And it might even make more sense to write r of theta. So r is a function of theta. So r equals something, right? It equals 10 divided by this, but these values depend on what theta is. So you can say r is, and I'll write it again here, is a function of theta. And that's a conversion from Cartesian to polar coordinates. And let's try another one of those. So now if we have y equals 4x minus, I don't know, 8, right, we have this equation now. Well, we know that from our list of tools that y equals r times the sine of theta, x equals r times the cosine of theta. So we're going to plug those into our formula. Instead of y, we can write r times the sine of theta equals 4 times r cosine of theta minus 8. So here, we want to actually convert from Cartesian to polar, right? And we're doing that by substituting these values into the equation. So what can we do next? Well, I'm going to subtract this term from both sides. So we get r sine of theta minus 4r cosine of theta equals negative 8. And now we're going to factor out the common factor, which is r. R times the sine of theta minus 4 cosine of theta equals negative 8. And we're going to divide both sides by this term. So r equals 8 over sine of theta minus 4 cosine of theta. And again, r is a function of theta. Right? We don't know what theta is, but we know that r depends on it. So r is a function of theta. And we can keep going with these types of examples. Let's try a few more. What if r equals 4 times the sine of theta? What do we do in this case? Well, going back to our tools over here, we have x squared plus y squared equals r squared. We have tangent of theta equals y over x. R sine of theta equals y. R cosine of theta equals x. So which of these can we use to apply here? I mean, I would go for perhaps this one right here. What we can say is, well, what is sine of theta equal to? Because that's what we have in our equation. Well, if I divide both sides by r, sine of theta equals y over r. So we can plug that in here, and it's getting us a little bit closer to our goal. Remember, the goal is to replace r's and sines of thetas with y's and x's. So we're getting there. R equals 4 times y over r, which is what we're saying sine of theta equals to right here in the context of this problem. Okay, so what do we do next? Well, distribute the 4, so you get 4y over r equals equals r, and from there we can just multiply both sides by r, and what do we get? Multiply by r. Well, r squared equals 4y, and this is pretty useful to us, right? Because now we know what r squared equals, and we also know, well, what is y equal to if we wanted to? Well, excuse me, what is r squared equal to? Now we're getting somewhere. Y is what we want to keep in the equation. Sorry about that. We want to get all x's and y's in here, and now we can use this equation. So instead of writing r squared, we can write x squared plus y squared, because that's equal to r squared, equals 4y. And we could probably keep going with this and rewriting it, but let's leave it here, because our goal was to rewrite this polar function in terms of x and y on our Cartesian plane. And like I said before, polar coordinates can make things very easy, and perhaps we'll see some of that in the next couple of examples. Here we have r equals sine of theta plus the cosine of theta. And here our goal is the same. We want to rewrite this in terms of x and y on the Cartesian plane, and x squared plus y squared equals r squared. Tangent of theta equals y over x. It keeps going, right? R of sine of theta. R times the sine of theta equals y. R times the cosine of theta equals x. What can we do here? We have sine and cosine. We don't have any equations that give us that exact value, but let's just kind of change these a bit. We'll take this one and divide r by both sides. Divide both sides by r. So the sine of theta equals y over r. And then I'm going to say, well, what if we did the same thing with r cosine of theta? Divide by r on both sides. We get cosine of theta equals x over r. So what can we do with that? Well, here's sine of theta, here's cosine of theta, and here's their equivalent values. The sine of theta equals y over r. Cosine of theta equals x over r. We're adding these together, which equals r. What happens now? There are many things we can do. I think it makes a lot of sense to multiply everything by r. So we get r squared equals y plus x, right? Just multiplying everything in this equation by r. And what can we do? Well, let's divide everything by r. I guess we can go back and forth, but that would just bring us right back here. And in fact, in this, what I would say is, and I keep missing this one, use this part of your toolbox, which is that r squared equals x squared plus y squared. That's what r squared is. I'm just rewriting that. And that equals y plus x. And we can rewrite this in different ways, but our goal was to rewrite this polar function into a function of x and y. And here are x's and y's. We've done that. And one last one. I like this one. What happens if r equals a to the fourth? Well, what do we do here? Well, let's think about this one, right? X squared plus y squared equals r squared, and we can also think about our other parts of our toolbox. The tangent of theta equals y over x, and the sine of theta, times r. What's that? The sine of theta times r. Well, sine of theta times r is y. The cosine of theta times r is x, and these are going to be helpful to us. What I would do in a situation like this is maybe consider thinking about, well, what can I do with r here? And at first glance it might not seem like much, but what if we squared both sides, right? Because if we do that, we can use this r squared part of our toolbox. So if I square both sides, if I just square everything, which is something you could do in equations, right? You do it to both sides, we get r squared equals, well, what's a to the fourth squared? That's a to the fourth times itself, and what we do there is add the exponents of exact same bases. So r squared equals a to the 8th power. And what does that mean? Well, we're not too sure about that, but we can say that since r squared equals x squared plus y squared, we can plug that into for this term. So we'll have x squared plus y squared equals a squared. A to the 8th, excuse me. So that what does that tell us? Well, it tells us what we have here is a circle, right? And in fact, this worked out pretty nicely. Anyway, so I hope that helped. That kind of covered a pretty wide range of problem types you might see. Again, x and y in the Cartesian plane, left and right. Polar coordinates aren't going left and right in the same sense. They're using a distance r and an angle measure theta. And that's what polar coordinates build from, right? This idea right here. Okay, hope you enjoyed it. Thanks.